Myself Prayak Patel, working as assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the all pair shortest path. In previous lecture, we already discussed the one method for the all pair shortest path using dynamic programming. Now in today's video lecture, we discuss about the all pair shortest path using dynamic programming, and method name is fluid Warshall algorithm. Here use fluid Warshall algorithm for find the all pair or all point shortest path. We already discussed there are two type or two method for the all pair shortest path. Now first one is matrix multiplication and shortest path, and second one is fluid Warshall algorithm. We already discussed the first method, matrix multiplication and shortest path, in our previous video lecture. Now in today's video lecture, consider the second method, and second method is fluid Warshall algorithm for find the all pair or all point shortest path. Now what is the fluid Warshall algorithm and how fluid Warshall algorithm will work? First, fluid Warshall algorithm is for find the shortest path between every pair of vertices of a graph. Means in a graph you want to find the path from the each and every node, means find the path from 1 to remaining all node, then 2 to all node, 3 to all node, like this. Means all to all shortest path find using the fluid Warshall algorithm. The graph is represented by adjacent matrix where the number of rows and number of column equal the number of vertices. Means for example, in a graph there are 4 nodes, then consider the 4 row and 4 column table or matrix. Here consider if there is an edge between I to j, means path from I to j is available, then m of ij equal to wij, means here consider the value of the mij equal to weight of the I to j. It's called the path from I to j, where wij represent the weight of edge between I and j. So here consider this method for find the all pair shortest path. Now understand this method using one example. Now consider the example as a find all pair shortest path for given graph using fluid Warshall algorithm. Here see the graph. In graph there are 3 nodes, node number 1, node number 2 and node number 3. Now here given graph is weighted graph and directed graph. Here compulsory part is given graph is weighted graph. So here consider the path from 1 to 3 and weight equal to 5. Second, from 1 to 2 consider weight equal to 8. From 2 to 1 consider weight equal to 2, and from 3 to 2 consider weight equal to 1. So consider this graph and find the shortest path from this graph. Now consider the first step of the dynamic programming algorithm is step number 1, characterize the structure of an optimal solution. Means you can derive the formulas for your problem. Now consider the formula for fluid Warshall algorithm. Now first formula is d of k ij equal to 0 if I equal to j. Here consider d of k means consider the table or matrix as a table or matrix D, and I and j consider the node number I to j, path from node number I to j. Here consider if I equal to j means consider the node 1 to 1, node 2 to 2, 3 to 3, 4 to 4, means n to n distance consider as a 0, means consider the self node as a 0 answer. Now consider the another formula number 2, d of k ij equal to infinity if no edge between I and j. If the path from I to j is not available, then consider initially I to j distance equal to infinity. Now third formula is d of k ij equal to wij if edge between I and j is available. So here consider these three formula as a initial condition or initial formula. According to these three formula, you can represent the initial matrix or initial table D. Now here third formula is d of k ij equal to wij, means you can represent the weight of the path from I to j in this place if the edge available from I to j. So consider this. Now first three formula apply for k equal to 0. Now what is k? K means here we write d of k, d of k, d of k like this. Means if k equal to 0 means consider as an initial step. So initial step, for initial step consider k equal to 0. Then these three formula applicable for only k equal to 0. If k is greater than 0, then apply the another formula. Now consider this figure. In this figure consider I to j if you want to find the path from I to j. Now consider k as an intermediate node. So if you consider the k as an intermediate node, then first find the path from I to k, then find the path from k to j. So here consider k as an intermediate node. Here k equal to 0 in this three formula means no any intermediate node are there. Consider only direct distance and apply these three formula. Now consider the k is available means value of the k is greater than 0 means k equal to 1, k equal to 2, k equal to 3 like this. Then apply this formula number for d of k ij equal to minimum of d of k minus 1 ij and second part is d of k minus 1 ik plus d of k minus 1 kj. So here consider k as a node number. So k equal to 1 means node number 1. So consider the k dk means for the table 1 consider d1. Initially consider the table d0, then consider table d1. In table d1 what is the our result? Result equal to d of k minus 1 means d of 0 ij, or second part is distance from I to k plus distance from k to j. So see in this figure, here consider the path from I to j. The direct path is not available, then consider distance infinitive. Then consider the second way as a distance from I to k. Then add this distance with the distance from k to j. So this formula is applicable for k greater than 0. Now consider our example. Here in example given graph is there. Now step number 2 is consider the direct distance means according to formula number 1, 2 and 3. Now first formula is d of k ij equal to 0 if I equal to j. Then second one is d of ij equal to infinitive if no age between I and j. And third formula is d of k ij equal to w of ij if age between I and j is available. So according to this three formula, first initially if I equal to j, then write the d of k equal ij equal to 0 means here first table d0 because here this three formula is applicable only when k equal to 0. So here consider d0 table, first initial table name as a d0. So here d0 table as a initial table. Now consider the location or length of the table. How many number of row and how many number of columns in this table? Here consider the total number of node in a given graph. Here consider the total 3 node in a given graph, node number 1, node number 2 and node number 3. So consider the 3 row and 3 columns. So our table size equal to 3 cross 3 or matrix size equal to 3 cross 3. Now I equal to j means block number 1 1, block number 2 2 and block number 3 3 means main diagonal consider as a 1 1, 2 2 and 3 3. Value of the 1 1, 2 2 and 3 3 equal to 0 according to first formula. Now consider the second formula. In second formula d of k equal to ij equal to infinitive means if no age between I and j means initially we consider the all the path as a infinitive. Now according to formula number 3 d of k ij equal to wij if age be available between the I and j. So according to third formula here put the value 1 by 1. Now first consider the path from 1 to 2. So here in 1 to 2 consider the value equal to 8. So put the value 8 in table 1 to. Now consider the next path as a path from 1 to 3 because for first row consider 1 1 as a 0, then 1 2 equal to 8, then 1 3. 1 to 3 path is available? Yes. Then what is the distance? Distance equal to 5, weight equal to 5. So consider 5 at location 1 3. Now consider the next path, row number 2, 2 to 1. Here 2 to 1 path is available? Yes. What is the value? 2. So consider the distance 2 in location 2 1. Now consider the 2 to 3 path is available? No. Now consider next path as a 3 to 1. Now 3 to 1 path is available? No. Then next path is 3 to 2 path is available? Yes. Then consider distance equal to 1 from node number 3 to 2. So this table consider as an initial table D0. Means simply we can say that in initial table you consider diagonal as a 0. Then if path is available, then put the weight of that path into table, and remaining all location consider as a infinitive. So this is considered as our final table for the step number 2. Now consider the next step, step number 3. In previous algorithm, means shortest path and matrix multiplication method, we consider one node as an intermediate, then any two node as an intermediate, then any three node as an intermediate, like this. Now in this method we consider specific node number as an intermediate node. Now in step number 3, consider node number 1 as an intermediate node. So no any one node as an intermediate node, but only node number 1 as an intermediate node. Means you can find the path from any node to any node, but consider only node number 1 as an intermediate node. Now already you have a table which have direct distance. Now consider the one by one location. Now here consider formula for the find the path or distance. Here consider the formula number for d of k ij equal to minimum of d of k minus 1 ij d of k minus 1 ik plus d of k minus 1 k to j. So here consider first row and first column. Why? Because if you consider node number 1 as an intermediate node, then path from 1 to any node or any node to 1 is not changed, because already direct distance are there. If I told that here if you want find the distance from the node 2 to 3, then consider 1 as an intermediate. But if you want to find the distance from 1 to 3, then 1 not consider as an intermediate, 1 to 2 not consider as an intermediate. So here consider first row is not changed. Why? Here 1 to 1 distance is not changed, then 1 to 2. If you want to find the distance from 1 to 2, then 1 as an intermediate node is not possible. Then 1 to 3, here also not possible. Then 2 to 1, then 3 to 1. These 6 conditions are not satisfied. So here consider first row and first column is not considered. Only we check the remaining element. Now here remaining element is 2 2, 2 3, 3 2 and 3 3. This 4 location consider as a remaining location. So here consider this 4 location. Okay. Now for the location 2 2. Already 2 2 equal to 0. No need to worry about that because this is considered as a diagonal. So here 2 2 distance is not available. Now consider the path from 2 to 3. In path 2 to 3, consider this infinitive value as an initial value. Now find the value d1 to 3. Now here we write d1. Why we write d1? Here table name equal to d1. d1 means node number 1 as an intermediate, then this table called the d1 table. So here d1 to 3 means consider node number 1 as an intermediate and find the distance from node 2 to node 3. So apply the formula I equal to 2, j equal to 3 equal to d of d1 to 3 equal to minimum of d0, because here k minus 1, k equal to 1. So d k minus 1 means day k 1 minus 1 means 0. So here consider minimum of d0 to 3, because here I and j as it is. Now second part in this formula is d0 to 1, because here consider I to k and k equal to 1. So consider 2 to 1 plus d0 1 3. So here consider k to j. So k equal to 1 and j equal to 3. So consider d0 1 3. Means here you want to find the path from node number 2 to node number 3 and consider node number 1 as an intermediate. Then this path is possible. First you move from 2 to 1, then you move from 1 to 3. So here consider green shaded line as your path 2 to 1 and 1 to 3. So here consider formula, and according to formula our next step is minimum of Here consider infinitive value as a first value because old value of location 2, 3. Here if you want to find the value for D1 table, then consider the D0 table for your next process. So in D0 table, 2, 3 location value consider. 2, 3 means row number 2 and column number 3. Here consider infinitive value. Now next value is D0, 2, 1. Now here 2, 1 location consider value 2. Now next value is D0, 1, 3. In 1, 3 location consider the value equal to 5. So consider minimum of infinitive, comma 2 plus 5. And 2 plus 5 equal to 7. So consider equal to minimum of infinitive and 7. Now minimum consider as a 7. So our final answer for the location 2, 3 equal to 7 for D1 table. So here consider value 7 and put the value 7 at location 2, 3. Now after that, consider the third row. In third row, already first column is not considered because here consider shaded line is not considered for the our operation because here consider 1 as an intermediate node. Now consider location 3, 2. In location 3, 2, consider here yellow shaded as our current state and green shaded consider as our past change value. So here consider 7 as our previous answer. Now for the location 3, 2, consider the path from node number 3 to node number 2. Path is available, direct path available, then weight equal to 1. But using node number 1 as an intermediate, any path is available from 3 to 2. So here no any path is available. So here consider 1 as it is, no need to worry about that. Now consider the next step. Step number 4, consider the node number 2 as an intermediate node. Now already in previous step in table D1 we consider node number 1 as our intermediate node. Now consider node number 2 in red shaded consider as a intermediate node. So in table consider row number 2 and column number 2 as our selected line, means for that column or that row no need to worry about that or no need to find any value for that row and that column. So here consider remaining block as a 1, 1, 1, 3, 3, 1 and 3, 3. But out of these 4, first is 1, 1. In 1, 1 no change, no any change are there because 1, 1 consider as a I equal to j. So already value equal to 0. Now check for the next location 1, 3. In location 3 here see the yellow shaded block as a block number 1, 3. In block number 1, 3 old value consider as a 5. Now check for path from node number 1 to node number 3 and consider node number 2 as an intermediate node. Path is available. Here no any path available from node number 1 to node number 3 using node number 2 as an intermediate. So consider 5 as it is. Now consider the next location as a location 3, 1 because second row is not considered because node number 2 as an intermediate. So here consider path from 3 to 1. 3 to 1 path is available. Here consider or check the path from 3 to 1 using node number 2 as an intermediate node. So here consider path as a D2, 3, 1 means here consider path from 3 to 2 first path, then consider path from 2 to 1. So in this graph here green shaded consider as your path from 3 to 2 and then 2 to 1. Now already you have a one value infinitive in that location, so consider both the value, means here according to our formula D2, 3, 1 means path from 3 to 1 in table number 2 equal to minimum of D1, 3, 1 comma D1, 3, 2 plus D1, 2, 1. So here consider 2 as a intermediate node, means 2 as a k, value of k equal to 2. So here consider next as a minimum of infinitive. Infinitive means here consider this location 3, 1 old value equal to infinitive. Now next value is D1, 3, 2 equal to 1 and D1, 2, 1 equal to 2. So here consider minimum of infinitive 1 plus 2. So here final answer is minimum of infinitive and 3, and final consider as a 3 as our answer for location 3, 1 and put the value 3 in location 3, 1. Now consider the next step. Consider step number 5. Step number 5 is consider node number 3 as an intermediate node. Means here consider red shaded block in this table D3. Here table name equal to D3 because K equal to 3. Here consider node 3 as an intermediate. And here see the red node in a graph as an intermediate node. So here consider node number 3 as an intermediate node. Now here node number 3 as intermediate node means not consider the row number 3 and column number 3 for our calculation because node number 3 as an intermediate. Now consider the 1 by 1 location. Here first 1 location not consider because this is a 0 value and diagonal value. So now consider next location as a location 1 2. In location 1 2 old value equal to 8. Now consider the D3 1 2 equal to minimum of D2 1 2 and second part is D2 1 3 plus D2 3 2. So here consider path from 1 to 2 because here consider 1 to 2 as our location. Here yellow shaded consider as our current location. So path from 1 to 2 you can consider node number 3 as an intermediate node. Then first path from 1 to 3. Then next path is from 3 to 2. So consider this path as a 3 to 2. So total value equal to 5 plus 1. Here consider 1 by 1 value. So minimum of 8 comma 5 plus 1. 8 occurs from the location 1 to old value of 1 2. Then 1 3 value consider here in this table as a 5. Then next 3 2 value consider in this table as a 1. So consider 5 plus 1 as a 6. So minimum of 8 and 6 consider as a 6 minimum. So here consider 6th value at our location 1 2. Now here old value equal to 8 but new value equal to 6. So new value is minimum. Then we change this value as a 6 in location 1 2. Now consider the next location number 2 1. Here 6 consider as a already past change value and 2 consider as our current location. So yellow shaded consider as our current location. So for the location 2 1 check path from 2 to 1 is available when we use the node number 3 as an intermediate node. So here consider path is available or not in this figure check. So here consider 2 to 1 direct path is available but using node number 3 as an intermediate no any path from 2 to 1. So consider value 2 as it is. Then consider this table as our final table because how many times you repeat this process. Here first initially consider the direct distance in D0 table. Now in D1 table consider any one node number 1 as an intermediate node. Then in next step D2 consider node number 2 as an intermediate node. Then next step consider node number 3 as an intermediate node. Means in given graph there are 3 nodes. Then consider node 1, 2 and 3 as an intermediate node. But if a given graph have a 4 node, 5 node then you consider 1 by 1 location as an intermediate node. After all the process here final table is table D3. In table D3 consider the value as a 0, 8, 5 in first row, then second row 2, 0, 7 and in third row 3, 1, 0. So this table consider as our final table for the find the fluid Warshall's algorithm for all pair shortest path. Means from all the node to remaining all nodes shortest path value equal to this. So consider this table as our final answer. Now consider the another example for your reference. Find the all pair shortest path for given graph using fluid Warshall's algorithm. Here consider the total node number equal to 4. So node number 1, 2, 3 and 4 consider as a 4 node. Now already each and every edge are there and weight of the each and every edge is given in this graph. Now consider how you can solve this example. Here consider table size or matrix size equal to 4 cross 4 because here 4 value 1, 2, 3, 4, 4 node. So consider 4 as a row and 4 as a column. Now initially consider the table D1. Initially consider table D0. In D0 table consider only direct distance. Then table D1. In table D1 consider the node number 1 as an intermediate node. Then this table is considered. In this case first row and first column is not considered. Remaining 9 location is considered and find the value according to node number 1 as intermediate. Then in D2 step Means third step consider as a table D2. In D2 table consider second row and second column, means not consider row number 2 and column number 2. Remaining all element find according to node number 2 as intermediate. In next step find the value of D3. In D3 table third row and third column is not considered and remaining value find according to node number 3 as an intermediate node. And final step is step number D4. In D4 consider row number 4 and column number 4, so not consider row 4 and column 4, and find the value as a node number 4 as an intermediate node. So in simple we can say that in fluid Warshall algorithm you have a 4 node, then consider up to the D4 table. If you have a 5 node, then consider last step as a D5 table. According to that we can find the all pair shortest path using fluid Warshall algorithm. Now in today's video lecture I discuss about the fluid Warshall algorithm, how we can find the shortest path from any node to remaining all node, means all to all shortest path find using the fluid Warshall algorithm. Thank you for watching this video.